Trillions
Iron, an
of
element that
dollars
makes
are
up more than
lost
30% of
annually
Earth's
due to
mass,
corrosion.
is the backbone of
The
every
cost
bridge,
of silent decay
building,
continues to
ship,
rise as our
and the
infrastructure
entire industrial
crumbles.
world. Yet hidden within its structure lies a paradox of survival. The same metal that built civilization constantly longs to return to dust. Whenever iron touches air, a slow fire begins not with flames, but through oxidation. Moisture and oxygen gradually penetrate the crystal lattice, breaking bonds and transforming Fe into Fe2O3 rust, a lower energy mineral form. Each year, this silent self-destruction is estimated to consume nearly 3% of global GDP losses worth trillions of dollars. Bridges fracture, ships decay, pipelines burst. The modern world stands on a material foundation that is always resisting itself. But amid this endless battle, humanity discovered a strange material, a metal that heals itself at the atomic level. When scratched, it seals itself. When corroded, it closes its wounds. And this miracle does not come from magic, but from the quantum chemistry of chromium. To understand stainless steel, one must first understand its enemy, oxygen. In the universe, all matter tends toward lower energy states. Oxygen, one of the most electron-hungry elements on the periodic table, drives that transformation. When iron meets humid air, surface atoms lose electrons to become Fe² minus ions. These ions react with oxygen and water to form FeOH3, which then dehydrates into Fe2O3 rust. The danger lies in rust's porous, brittle nature. It cannot stop oxygen from penetrating deeper. The process advances inward, layer by layer, until the entire structure disintegrates. In other words, rust is combustion in silence. No flames appear, yet oxidation continues slow, relentless, and seemingly unstoppable. From a thermodynamic perspective, this outcome is inevitable. In nature, iron ore is the stable state, while steel, a product of metallurgy, is merely a temporary act of resistance against entropy. Physics dictates that refined order eventually drifts back toward disorder. Yet, at this precise point, humanity found an escape if oxygen cannot be defeated. It can be partnered with. In 1913, metallurgists discovered that adding at least 5% chromium to an iron alloy fundamentally changes the oxidation process. Chromium, which has an even stronger affinity for oxygen than iron, reacts first, forming a thin layer of chromium oxide, Cr2O3, on the surface only a few nanometers thick, about 1,000th the width of a human hair. What makes this layer extraordinary is that it is not a paint or coating. It is part of the crystal structure itself, bonded directly to the metal beneath. Whenever the surface is scratched, oxygen immediately reacts with exposed chromium atoms, rebuilding the Cr2O3 layer within milliseconds. This phenomenon is called passivation, a state of controlled reactivity. Instead of fighting the environment and the material compromises with it, it accepts limited oxidation in exchange for long-term stability. This mechanism turns stainless steel into a regenerating metal. Electrochemically, the Cr2O3 film has a dense crystal structure, insoluble in water, and nearly blocks the movement of electrons and iron ions. As a result, oxidation is halted at the surface. A tiny scratch, something that would doom ordinary iron, becomes an opportunity for stainless steel to breathe and renew itself. Creating stainless steel requires more than simply adding chromium. Metallurgists must reconstruct iron's atomic architecture inside electric arc furnaces, where temperatures reach about 600 degrees Celsius, comparable to the surface of a red dwarf star. Within this storm of heat and electricity, iron, chromium, nickel, and carbon melt together. Atoms rearrange into different crystal phases: austenitic soft, ductile, non-magnetic like the familiar 304 grade used in kitchens, martensitic hard, used for knives and surgical tools, and ferritic, more affordable and heat-resistant. These phases differ in how iron atoms organize within the crystal lattice. Austenitic structures are face-centered cubic, FCC, while ferritic structures are body-centered cubic, BCC. These arrangements define mechanical properties from flexibility and hardness to corrosion resistance. On a physical level, stainless steel is a multi-layered architecture of energy and order. Each atom is positioned to balance three forces: mechanical strength, chemical reactivity, and surface-free energy. Stainless steel is not merely an alloy, it is an atomic machine designed not to die. One of its most extraordinary properties is the ability to self-repair without external energy. When the surface is cut or polished, the Cr2O3 film breaks. But in the presence of oxygen, even in trace amounts, exposed chromium atoms instantly react to form a new oxide layer. Atomic force microscopy, AFM studies show that this regeneration occurs in less than a second and stops once the film reaches a stable thickness of about 2–3 nanometers. This is the optimal balance, thick enough to block oxygen, yet thin enough to preserve the metal's reflective shine. The process resembles how human skin heals after a scratch. Epidermal cells regenerate seamlessly. Because of this parallel, materials scientists sometimes call stainless steel metallic skin. Interestingly, this mechanism only works when a minimal amount of oxygen is present. In oxygen-deprived environments, such as a vacuum or stagnant water, stainless steel loses its ability to breathe. The protective film cannot reform, and corrosion may begin. Thus, the paradox returns to avoid destruction. Stainless steel requires a touch of destruction, a small dose of oxygen to sustain its life. Stainless steel stands as a symbol of intelligence made tangible. It does not attempt to defeat nature. It learns to coexist with it. It borrows its greatest enemy, oxygen, to create a shield. In every building, every knife, every spacecraft, there exists a metallic skin, thinner than paper, yet stronger than time. Stainless steel is not immortal in a religious sense, but immortal in a physical one. It reaches a balance of energy where entropy can no longer easily advance. And like many profound scientific stories, its journey begins with a paradox to endure. One must accept transformation. Perhaps that is also a lesson for humanity, creatures that chase perfection in a world filled with rust. Not everything must resist the laws of nature. Sometimes, the only way to survive is to learn how to rust in a controlled way.